In section 3.2, I will be talking about polynomial functions. Since this is a longer section, I'll be breaking this down into multiple videos. Let's begin by talking about the polynomial. The degree of a polynomial is the exponent that is largest. The leading coefficient is the number in front of the term with the biggest degree, or biggest exponent. Let's take a look at some examples of functions that are polynomials, and then some examples of functions that are not polynomials. The first example is a polynomial, f of x equals negative 3x to the fifth plus 2x squared plus 5. This polynomial is in general form. Let's take a look at the next example. That is also a polynomial. F of x is equal to negative 3x to the fourth times x minus 2 times x plus 1. This again is a polynomial, however this time it is in factored form. The next two examples, however, are not polynomials. Let's find out why. The first example, f of x is equal to negative 2 times the square root of x plus 5. This is not a polynomial because of the square root of x. If I rewrite that as x to the 1/2, its exponent has a fraction, and that cannot be a polynomial. Next, the function f of x is equal to negative 3 over x squared plus x squared plus 2. Again, this is not a polynomial. Why? Because the first term, negative 3 over x squared, is a fraction. If I move x squared to the numerator by making it x to the negative 2, its exponent is going to be negative, and a polynomial cannot have a negative exponent. Next, let's take a look at two examples graphically of what a polynomial does and does not look like. The first graph is a nice smooth curve moving up and down. That is a polynomial. However, the second graph has sharp peaks that make the shape more of a V. That is not a polynomial.